Today we have an amazing guest, Sven Shockey, FAIA from SmithGroup. Sven, welcome to the podcast.
Oh, thanks. It's good to see you both, and it's good to be here.
Good having you.
Yeah, I am excited because we're talking about a project that you are intimately familiar with, Sven, right? This is one of those things where you get to share your passion for this project beyond delivering it to the client, right? Like I'm sure you've had this amazing relationship with this project, just as we all have with projects over the years. And then it's like, okay, that project's done, on to the next one. And so now you get to kind of be nostalgic and bring that to our audience and talk about this amazing project. Maybe you can introduce yourself and the project to us.
Yeah, sure. Yeah. So my name is Sven Shockey, and I'm a design director at SmithGroup. And so this particular project, it's Virginia Tech Academic Building 1. It's Academic Building 1 is because there are some future buildings as part of this campus, because this is a brand new campus in Northern Virginia.
Nice.
And so I can go into a little bit of the context of why it's in, this building's in Alexandria, Virginia. Virginia Tech campus is about 5 hours west in Blacksburg, Virginia. So Virginia Tech is a land-grant university, and they've had a presence in Northern Virginia for some time, but they wanted to bolster that presence particularly once the Amazon HQ2 pursuit started happening 6 years ago, or more than 6 years ago.
Yeah, can you kind of set the scene for how this project even happened? I mean, that's kind of you just got into it a little bit, but I don't want to gloss over that. I feel like it's interesting how projects show up, how they start, and the story behind that like nobody knows when they go visit a building. And so I think this is kind of a cool chance to just talk about one of the weird ways that a project got started. Right.
Yeah. So what happened was, Virginia Tech has had a presence in Northern Virginia for quite a long time, but it was located at different locations and in different kinds of programs. But once the state of Virginia heard about the Amazon HQ2 pursuit, they aggressively pursued it, as did, I think at the time, you guys I'm sure remember, but almost every city.
They were competing, yeah for sure.
Yeah. In North America, they were competing for it and kind of outlining what the advantages were for their geography. But so the state of Virginia thought, boy, if we can kind of bolster one of our academic institutions in Northern Virginia and create what they were calling at the time a tech talent pipeline. So if they could have kind of a strong presence of research and students moving through a tech program, then they could feed the tech industry. And of course, Northern Virginia is one of the kind of the strongest areas for the tech industry, with the federal government and a lot of commercial interests. And the tech AOL started in Northern Virginia. Most of the data centers, there's, I think, one of the largest concentrations of data centers are in Northern Virginia. So it was to create an ecosystem. So they worked with Virginia Tech to create this ecosystem. So it's combining government with industry, with academic research at this location. That's what they did. So it was a series of kind of interviews for the project as a public institution. So it was very wide open. So there were, 50 firms that initially kind of went after the project.
I want to give our audience a fair warning here that this show is going to contain visuals. And so if you're listening to the audio version, you are missing out on half of the content here, at least, because Sven is going to be very graciously sharing his screen with lots of images that are going to take us through the process and show the final images of this incredible project. So you head over to our YouTube channel. We'll have a link to it in the show notes for this episode so you can easily find it. And I recommend that you watch this one if you want to get a real view at the stuff that we're going to be talking about, because it's going to be hard to translate that to just a pure listening audience. But Sven, how long have you been at SmithGroup now? Can you talk a little bit about kind of your journey? How long did this, and like how that led into this project and how long this project took? Because we have a lot of students who listen to this show, and I think it's just one of those things to give a little bit of visibility to what it actually takes to do a project in the field of architecture.
Sure, yeah. So I am a Virginia Tech alumnus, but I was in the master's program, but this is back in the early 1990s, so it's been a long time. I started at SmithGroup in 98, so 27, 28 years,
Wow,
quite
cool.
quite a long time. And so working on this project was particularly, I think, interesting in that it was connecting back to my alma mater, and it was a different program. Of course, this is computer science, computer engineering. It's not the School of Architecture, but I think a very rewarding project for that reason.
There's that sense of pride that you had because you're working on your alma mater.
Exactly. I had some insights into kind of institutional identity and that sort of thing. And of course, this project is very different from the main campus, and that was part of what they wanted. This was a kind of reinvention of what is a land-grant university in a different location when it's extending its mission to the ecosystem in Northern Virginia. So it's a kind of a different.
Can you explain what that term? What does that mean? Land-grant university.
So I think initially in the 19th century, I think every state was awarded land to develop university. So I think most of the state institutions in the United States are land-grant universities, and they all started with that land-grant process. And many of them were maybe focused on agriculture or very, very different focus than what you see now, right? So they are in these very remote locations. So I think University of Illinois, Virginia Tech, a lot of the 8 schools, right?
Yeah, so actually to add on to that, because we do a lot of university work and do a lot of land grant as well. Plus, I am a alumnus of another land grant university, Auburn University, and it was predominantly focused around in the late 1800s. There was basically that big push towards creating university institutions that were focused around agriculture and industry. And so they would give that, and actually, I'm not going to derail this, but there was this nice big,
but you could,
nice big fun battle between Auburn and Alabama to get those land grant fundings. So it is
my
really
alma mater
interesting.
also was known for its agriculture program. I mean, I assume that's probably for the same reason.
It's really interesting to kind of like see the evolution of land grant universities and stuff.
Yeah.
Yes, I think many of them are kind of reinventing themselves or seeing themselves in a different, so they still have the same mission, but they have kind of so much more kind of breadth of connectivity with the rest of society now. So
yeah,
that was a significant goal. This was to develop a brand new campus in Alexandria, Virginia. So this is right across the river, or right across the Anacostia River from Washington, D.C., and so there's all this industry right there. The project's right next to DCA Airport. If you've ever flown into Washington, Amazon HQ2 is maybe just a mile to the north. Even from this building, there are views of the river, Northern Virginia, and the monumental core of Washington, D.C. So it's kind of very, very well situated.
That's cool. So let's talk about the project here. I mean, you've got an image of kind of a very abstract image up on the screen, but let's jump into it.
Yeah, so this is do you see the video that's playing?
Yep. Yes. Mm-hmm.
Okay. Yeah, so this is just a overview video, just because it gives, I think you can kind of get the big picture of the site, proximity to Alexandria, to the airport, to Washington, D.C., and you notice all of the faceting on the facade, which I'll talk about, the reason for being, and the articulation incorporating photovoltaics into the facade. Some warm, we wanted to kind of bring this really human-centered attributes to the project. So warmth and light and wellness attributes. So we can talk about that there are these fins, these vertical terracotta fins on every facet, even though it's incorporating different photovoltaic technology. So
nice.
It's kind of combining that the technology with kind of the warm attributes throughout the facade.
And this thing is like an object, right? So I'm curious, just from like a campus planning, you said this is the first academic building, right? So did you guys do any kind of master planning, feasibility kind of stuff? And this fits into a bigger plan, or is this just kind of like the stake in the ground?
Right. Yeah. So right around the time that Virginia Tech was looking at a number of locations in Northern Virginia for this campus, and they finally found this one, which is really just ideal because of its proximity to everything around it. also close to Metro. So actually a new Metro station was built for this project and for some of the development that was going to happen around the project. The university developed a very quick master plan before we got involved. And so we basically, when we won the project, we had a master plan which just basically identified 3 building footprints. They understood which was going to be the first building to go up and what the density would be and the zoning requirements and all of that. So then we developed this first building that you see, 300,000 square feet, computer science, computer engineering. But then there are 2 actually surface parking lots which will go away. They're going to be the future buildings. Each one of those is 150,000 square feet.
Nice.
So there's a little bit of a campus too. So we've got some hardscape and some lawn and bioswales and rain gardens, that sort of thing. So if you're a student or faculty and you're hanging out here, you've got that whole kind of campus feel with benches and references. We could talk about that later, but references back to the main campus in terms of materiality. And in particular, a stone, they call it Hokie stone. It's a dolomite limestone that's found in the region.
Knowing Alexandria pretty well and knowing kind of like the traditional architectural style that you see mostly there, how is this received as very evocative, very cutting edge? How is it received locally?
Yeah, so it was very interesting because we had this project, we won it in 2019. We kind of had 2.5 years, let's say, to design it, 2.5 years of construction. But there was a lot of momentum for this to happen. And we had a whole series of presentations there. This small area plan has a Potomac Yard design review board with that we had to present to, and the community, and then even the state of Virginia. But I think it was actually interesting because many of the comments were like, well, we're used to seeing brick in Alexandria. Right. Alexandria is such a brick-centric kind of place, right? And the historic references, and there are lots of historic row houses, new brick row houses, but very bricky. So, but I think almost everyone we presented to, though, kind of understood that this was a future-facing building. It was really about the future. It was about kind of optimism about the future, right, about technology and all those things. So actually, even though the context was this, there is historic context not too far away, and that kind of culture and expectation for architecture in Alexandria, it was very positively, I think particularly once the story was told for how the form was developed, which we can talk about. And because you might look at it initially and just say, what is that? What's the basis of it? Is it arbitrary? Is there a rationale? But I think once we were able to tell the story, it was very well received.
Well, tell the story. I think that was a perfect segue because, I mean, there's like the visual thing I see, the interpretation I tell myself of what that could be. Obviously, it could be a lot of things. So what is the design story for this building?
Sure. Yeah. So I think we wanted to go back to first principles on this building. And so this is a little bit, actually, maybe I'll just take a side step here just to look at this is the context. This is actually, I should have shown this earlier, but this is the plan of the 3 building sites, the first building and then the 2 other ones. And then this is the context for the larger neighborhood once it develops. So right now, there's everything to the south of the building is actually just ready to go, blocks ready to go. So the utilities have been placed in there. And a lot of this was supposed to be built. But after COVID, it changed the dynamics of the business model, basically. So what was going to be, these were going to be office buildings, some mixed use, some residential buildings. Many of them were actually designed and ready to go. And then after COVID hit, it just changed the whole picture. So those will go up eventually. And then everything on the west side here right now is kind of retail now that is temporary and that will be replaced by an urban grid of streets. So that just kind of sets the context. But I think the first question when somebody sees the project is usually why is it faceted? Why does it look like that? And what's the kind of the rationale behind it? So I think we call it a heliomorphic form is like kind of just like a simple way to think about it, which is just to talk about Archispeak, right?
Yes, so, I'm so glad you said that. I want one of those bells that sits on the hotel desk to ding it when Archispeak actually happens on the show, exactly. Because it's like it doesn't happen that much, but when it does, it's great. Thank you.
Yeah, I thought it was required for the show.
No.
That's
We're totally the opposite.
Yeah, no, I'm kidding. But I think it's just such a simple idea in that it's a form that's developed around the movement of the sun, right? And it's just it really is that. So I think initially Virginia Tech had very clear kind of aspirations for the project and principles for the project, and they had to do things like a really high level of sustainability, integration of technology. Campus identity was very important to them, wellness, all these attributes. So we went back to first principles. Typically, a project, if you're going to maximize the kind of level of sustainability, maximize the systems, and then you might incorporate as much photovoltaics or geothermal or other technologies. So, but we were very interested in photovoltaics, to see how much power we could generate on site. So we initially were thinking, okay, this could be a very horizontal building. But when we actually won the project, we discovered that the zoning envelope that they were thinking about was actually a very tall building, 200-foot tall building nearly, and 300,000 square feet, about 11 stories equivalent. So we weren't going to be able to integrate all that much rooftop photovoltaics. So we thought, well, maybe we could incorporate them into the facade. So so this kind of half dome that you see here, basically, it's just very simple idea, right? If you have a half dome, and those are just all of the possible exposures to the sun, right? So it kind of tells the story about which ones would have the best potential for generating power. So the more orange in this diagram, the more deeper the orange, the greatest potential. So, photovoltaics are always placed on rooftops, but what the diagram shows, I think, is it's really the south-facing part of the half dome, or even southeast and southwest. Those are the kind of the highest performing surfaces.
Can I want to raise my hand here. So two things. And don't take this the wrong way. When I think of first principles, I think passive design, right? I don't think like maximizing the units and photovoltaics and things like that. So I am curious where they were coming from when obviously infusing it with technology. I think part of the answer is maybe in my second question, which is something that I'm sure you both could speak to a lot more than I can, which is like clients want to base decisions on data, and they want to be able to justify decision making, especially in the future, on really solid data metrics. So when it comes to sun exposure and stuff like that, right? It's like, okay, well, we made that decision because this is the actual data. So can you talk through that process? Because coming from the West Coast side of things, thinking of like Palm Springs, where there was more like the birth of modern architecture, it was like, well, it had to be on this budget, but also like we just have this climate to deal with, and it was that we didn't have the incredible HVAC systems that they do today, and so super long overhangs, big deep shadows, right? Was like trying to grab the breeze. That was all like the passive design first principles that that we were taught in school.
Yeah, but I think for this climate,
different than California, for sure.
Yeah, totally different. So we have down to the single digits in the winter, and then we have up to over 100 degrees or 100 degrees close to it in the summer. But
humidity.
Also, that's the factor, humidity.
Yeah.
So there are very few days where you can really use a passive approach, particularly for a 300,000 square foot research building, right? I mean, the amount of kind of heat that is generating on its own, just from its own experimentation and from human beings in the building. So energy modeling is part of this whole process. So we have a sense of a starting point, and then we just kind of incrementally make it better and better. So one of the ideas at the very beginning was about electrification. So we recommended that the building would be all electric, which is actually rare in this climate for an all-electric large research building, so no combustion on site. So the idea being, of course, that as the grid gets cleaner and cleaner, that the building can receive the benefits of that over time. So all electric buildings, so therefore any on-site power that we can generate will kind of help the kind of the process. And I think also part of it is expressing these ideas about technology actually ameliorating certain situations and making things better on projects, but expressing it, right? So it's not going to solve everything, but it starts to kind of point to the future of how to think about buildings, that they can really be adapting as much as possible to their surrounding and their context. I think what this diagram shows is we developed, so once we were going to explore the possibility of using the photovoltaics on the skin, on the facade, we had to explore what kind of geometry could facilitate that. Should it be hundreds of small facets, or should it be just like one slope facing south? Or it's kind of an open question, right? And there's obviously, if you had just a giant one-story building, you'd have this giant roof area. But if you really are trying to explore the facade, and of course you've got limitations. You don't want the angles to be too steep. You don't want to have wasted space. You don't want to lose square footage. So we have an in-house team that kind of works on these kinds of questions. And so they developed a Grasshopper and Rhino script and it actually permutated through 1,400 different iterations to try to answer that question. And so you can see at the bottom is it would go through it would start with the zoning mass, and then it would start to bend and fold it in every conceivable way, just to get a sense, because what we were looking for is something non-intuitive, right? There's all the rules of thumb for how to do, like you were saying, Evan, about passive design, and there's all the rule of thumb about where to place windows and all the sun angle and analysis that's been done over time. But if we were to like really think about it from scratch again and let this thing run through, what would it tell us? And so the result was just a very small number of large, well-oriented facets were the most effective for the project.
So it basically comes down to performance, like selecting the sweet spot of things to focus on to say, okay, this is the direction, and then you can start whittling it down from there.
Yeah, I think it was just to kind of point to a direction that could be explored further, right? So, and then there are all these other kind of attributes and areas of exploration. So, for example, on the west side of the building, we knew that there was a plan for further development. So we weren't going to be able to use the southwest facets. So this thing is really oriented south and southeast in terms of the photovoltaics. But then we had all the other considerations. We needed program space that was in the right arrangement and usable. Then we started to carve in areas for terraces. The ground floor, we kind of set back so that there's an overhang around the entire ground floor. So there's a lot of sculpting that was going on based on this initial research.
Well, you said that you were kind of taking a non-intuitive approach, but in a way it also feels very intuitive as well, because you're taking into account things like zoning, future development, sun angles, where you can maximize those sun angles, and faceting it just to the right exposure so that you can maximize the energy consumption or energy production in those particular locations and stuff like that. I mean, I'm in a way sort of excited to show some of my students this episode so that we can start talking a little bit more about how buildings can actually think through some of the simple things that we're always teaching them about, which is how do you either harness or kind of push away like that sun exposure, that solar heat gain and things like that. But then how does that inform the design of the building?
Exactly. So it's a back and forth, right? We have all these incredible tools now, so we can learn things from the tools, but there's still the whole toolbox of architectural techniques and ideas. And so it's this back and forth of we have data, but then we also have human experience and urban form and context and everything else.
I think this kind of points to this idea that, Sven, that you're talking about right now is there's this idea that, especially with AI, right? It's like you prompt something and you get a picture, and it's like it's like this idea of something being this interactive process, and that it is actually not. There's maybe some speed, but speed is not the point. Like when you're talking about 1,400 iterations, yes, okay, I need to go through those kind of quickly and whittle out the ones that for sure don't make any sense, and then just focus on the ones that do. But really, it's this real back and forth process, and like the interventions that the designer needs to be able to say, okay, now that we know that, we also have this that plugs in at this point in the timeline of the design process to say, okay, new thing that needs to be considered because it's obvious to me as a designer, but the computer doesn't think like that, right? And so it's like, it's that kind of intervention and interaction that is the process of doing this kinds of data-driven design.
Exactly. And another factor was the airport, right? So we were right on the flight path of DCA. So the fifth facade is another consideration. In this case, it's like the 17th facade, right? Because the whole thing is faceted.
Every angle.
Yeah.
But it was a real opportunity for there to be a presence and an experience from the sky, which is something we didn't bake that into all the computational stuff. That's just part of architecture exploration.
Well, speaking of that, because that was actually a question I was thinking in my head, is like, so you are on the flight path to national, and the interesting thing about this is not only what you see from the ground, but what kind of like conversations did you have to have with, like, say, FAA or things like that because of the faceting of this? Did you have to like basically prove to them we're not going to blind the pilots and things like that?
So we submitted the geometry to FAA, and it took them a long time to get back. Because I think
I'm sure it's a well-run organization, Sven. I'm sure.
Right.
Yeah.
So I think it took a long time to evaluate, but the fact is that every building, any glass building, is going to reflect light in various directions, right? This has maybe a few more facets, but we have kind of an internal tech team that can do that did this study, and I love it because we can ask them any question and they'll kind of figure out the answer by all these new tools. So, but one question was exactly that: what is the glare? What's the impact to maybe the control tower? And they looked at all that, and they found that there was a huge source of glare, and that was the river.
Yeah, true.
So, think about how inconsequential any of the buildings are in the area compared to the river.
Right. You're like, yeah, the building definitely is going to blind you, but the river is going to blind you way worse. So we did adjust a few facets to be a good neighbor. I think it's really probably negligible, but it was interesting that with this kind of design where you're sculpting it, there's so much criteria that you can use to sculpt. It could be internal, program driven, or all the kind of the urban design considerations and context or performance, any of those things.
Yeah.
And you're showing this video right now where you're kind of going through iterations. And I think there's like an intuitive sense that designers already have, which is like, well, yeah, the southeast facing is going to get a lot of solar exposure, but you can actually measure it with a tool like this, and you can get the data to reinforce the decision, help you hone in on getting more precision in your decision-making process, right? As well, like there's still reasons, even if, yes, okay, we already know when this location and this orientation and these things, that these are the things that you inherently know about the project because you've done lots of projects, and a tool like this just actually gives you the data to back up that decision making for one thing, but also hone in on smaller and smaller aspects as the design process continues, right? You're constantly zooming in to smaller and smaller pieces of the project to focus on.
Exactly. Yeah. So this is that exact study is as we started zooming in, because that last study was really the overall form, and then we sculpted it further, but then we had to look at each individual facet and identify we thought it was just an interesting opportunity, because usually if a building might have 4 facades or might have some number of other facades, but this building really does have, I think, 17 different facets, right? So we could start to think about what does that mean in terms of the skin of the building? How would you, what's the best way to think about articulating each one, right? Mm-hmm. So So this diagram, I think, explains it. So these are the southeast facets. So for those, we used building integrated photovoltaic. So the silicon cells are in the outer light of insulated glass.
Okay.
So it's a regular IGU, but the outer layer is laminated with the silicon embedded in it. So it's basically almost like a regular PV panel, but it's transparent. So you can see, and we left areas without any cells, so you get a view, you can really see, but then we get this light that kind of streams in through the gaps between the silicon. So
is the silicon itself opaque, and then you have these gaps in between, or is there some level of transparency to it or not?
Yeah, they're pretty much opaque, but you do get, you get a little bit of a glow through them. But but you do get a lot of light through the gaps in between.
Yeah.
And then we did a whole bunch of studies identifying how much gap did we want. We could modulate that.
Oh yeah.
Think about it, Evan, as kind of like a large fritting.
Yeah. Okay.
Yeah, exactly. So, and I can show you later. We have the interior photo, so you get the kind of experience.
Yeah, I'd love to see a close up. It's like just you start to think about all the things that it takes to get that energy into some other system, right? Whether it's obviously it's got to go to storage or get used in some. And so now you start thinking wiring, and you start thinking all this stuff and embedded in glass, and how does all that work? And I assume it's pretty clean overall, but then it's like my mind just going through it. It's like, wow, there's a lot going on.
Yeah, and
yeah.
And Sven, I know you're probably going to get into it, but I mean, to go even further into a lot going on, I mean, you've got obviously the performance that you were talking about with just the energy harvesting, but now there's like all these different facets that have either providing both challenges and opportunities for solar to avoid glare, or to provide the views to reduce solar heat gain, and all of these other things. And it's almost like a study of, it's like when we're learning in school, it's just like, okay, how do you control direct southern light? How do you control western light and things like that? Sure. And then here you've got this, well, how do you do all of it at once?
In a glass box. Yeah, you got a glass box, right?
Yeah.
And the difference between something that's facing east and something that's canted a little bit more from, maybe a little bit.
You got your simple 90 to versus all the different angles, and you're just like, okay, now what?
Right, exactly. So it was a really kind of fun exercise, because we study things like this on different buildings, but here we had sort of all of the conditions at once, right? East and west facades, then it's pretty conventional glazing, but then we have the terracotta fins get very deep. So we have some of the fins are over a foot deep, and we kind of modulate them. So they're really cutting down on a lot of the glare and a lot of the solar heat gain. And then what you see actually, so parallel with the building is actually a spandrel glass that has an acid etch on it, and it's color matched to the fins. So it kind of adds that warmth to those sides of the building. So, and then on the south, this is where we have the horizontal PV. So this is also PV sandwiched between two layers of glass. And so then we could kind of play with the spacing and the depth and the angle of it to optimize that.
So you're using the same glass system, but just in a exterior fin system?
Yes, but it's not insulated, of course, in this instance. Right. But yeah, that's the same idea, that it's just a laminated glass with the PV in it. So you get this strong texture. Mm-hmm. But what you can see is, and of course this is a technique where you use horizontal fins on the south, so you can see right through it. And of course, in the summer, it blocks a lot of the direct light, in the winter lets more in. But it's a lot of surface area, so you can think about how much surface area of PV that is. Mm-hmm. which is really part of the story. So I think this was another kind of analysis to identify for every facet what was the right spacing, depth, and angle of every single fin.
Yeah,
amazing.
So that's how it modulates a little bit on the south facade based on the exact angle, and then so this takes into account, of course, PV, power generation, but also, like you mentioned, glare and solar heat gain as well.
Yeah, and the words on the page for those paying attention is optimization, right? Like this is, you have to meet You have to find the sweet spot for all of that stuff. You want to maximize the view, you want to minimize the glare, you want to minimize the heat gain, right? And so all of those things are basically, variables that you can measure with the computational design going on here to give you the best places to hone in on it. Like you've got the graph on the left there that really starts to show you where you're optimizing that performance with all of those different things that you're studying.
Exactly. Yeah. And then, here you can just sort of see the result of it with a little bit more closer look to it.
Very cool.
Yeah, what's even amazing about all of this is just the shadow depth. Should I say it, Evan? The shadow play?
You should say it. Oh, it's your favorite thing.
Right. Yeah, no, I mean, so I think one of my favorite aspects of the project is really when you're on the interior and just the shadows. I mean, the shadows are just very interesting, especially in the morning, because on the southeast is where the building integrated PV image on the right, and so you get this projected grid of shadow on the interior. That's very interesting.
Can I ask a question before we move into wherever you're going next with the interior? I'm just curious. Did you guys ever have a point along? This never happened, so I don't expect the answer to be yes. I'm just kidding. Like where did you have a major, we have to go in a completely different direction, or like just a big thing that shows up in the design process where it's like, we didn't have that information before, now we have to react to it, and that's potentially sending us down a completely different path. Did you have stuff like that show up during this project?
Yeah, I mean, I think one aspect of the project was that the schedule was pretty intense, right? Because they had this was going to open in 2024, 2025. That was their goal in 2019, right? So we had to maintain the schedule. So it was interesting that we actually designed the exterior before we had all of the interior programming worked out. So we had to really design for flexibility this whole time. And so because we had to, part of it was the schedule, we had to get through entitlements, and we had to understand cost, all these things at the same time. And we knew it was going to take longer to actually get all of the labs, the interior labs all worked out, meeting with all the different user groups, understanding instrumentation, understanding requirements. So we were kind of on a fast track for this entire facade. So, but I think we kept it flexible in that we said, for example, we were going to have areas where we had to make sure that we were getting the right views out everywhere. There was flexibility. On the west facade, we have areas where we open up the aperture, even with using the same vocabulary, but we kind of have less spandrel and more glass, so we could kind of open it up to the neighborhood in selected areas from the interior of the building. So we had to design a certain amount of flexibility into this whole system.
Yeah. Let me ask you.
And I imagine rigor. Cormac and I have had this conversation way before, many times, where it's like, okay, with labs especially, like structural module really matters. It really matters. You can't have columns coming down in certain places in your labs, right? And so I would imagine, like, if you're just working on the exterior skin, like, you still have to think 20 steps ahead. You have to be thinking about the structural system and what will work and what won't work with this exterior skin that you're designing.
Exactly. Yeah. So the whole building is all on lab module. So even the office spaces, in case they ever in the future. And so we had to decide which areas we're going to convert over time too, and make sure we dealt with vibration and have the ability for exhaust, because the labs are maybe limited on day one, but then it could go in any direction on day two. Yeah, so there was a lot of that.
So let me ask you, since I actually started construction on a lab building just north in Baltimore in 2019, actually technically 2018. But then as COVID started to come up, it started to kind of like reshape and rethink a lot of things from this particular institution and what they wanted to see within their labs. Did
like program-wise or specific use cases of the labs that were?
Kind of all of the above, to be quite honest with you. And so I'm kind of curious if with this during being designed and built during that same similar time, if you faced any of those similar challenges.
Right. Well, yeah, no, I mean, very much so. And you can imagine this is all during COVID, right? So we had a handful of meetings in Blacksburg to meet the client and start design. and then COVID hit within like a few months of design.
Yeah.
So we were trying to rethink is there going to be a new academic model for classrooms? And so we actually do have a video production studio in here, because they were thinking that they may have to actually produce a lot of the classes and distribute it virtually. Although we would probably do that for a lot of projects anyway. But we do have, and actually there's an outdoor classroom, which is actually kind of near this kind of stone area. There's a terrace kind of to the left here. I don't know if I have an image of it, but it's basically an outdoor classroom. So we could think in terms of outdoor, kind of greater usability of some of the outdoor spaces. So that white sliver of glass you see on the left, you can actually, we have a whole series of those slivers, but it's writable white glass. So you can actually write on it as you would for a classroom situation. But I know, kind of layer on top of that of COVID, in fact, this is computer science and computer engineering. So think how much that has changed in the last 5 or 6 years. So, and we had always planned on a drone cage and next few wireless research, but machine learning and AI, of course, took off during that time. So there was kind of more machine learning, AI. And then I think just organically, I think the business school really kind of grew their footprint in this building as well. So we had to accommodate for sure lots of changes on the fly.
I'm loving this Hockey stone.
Yeah, so if you've ever been to the Virginia Tech campus, and a lot of these land-grant universities, of course, are very historicist styles. So they've got the random ashlar Hockey stone there you can see on the right. That's what their campus buildings all look like. So, but the university architect was really great that she kind of challenged us. She said, well, for this project, we do have to include Hockey stone, but it should be reimagined in a more kind of urbane context. And so that was our challenge. And we were, of course, very happy with that as a starting point, right? So what you see on the left is basically this is from a quarry that's owned by the university, that they don't sell their stone, they only use it for their campus buildings. So it's instead of rusticated and random ashlar, it's all cut to precise dimensions. But it's interesting, these are actually saw cut, not honed or polished. It's very kind of atypical because it's really just cut in the quarry, and that's it. We really appreciated, and you can see it on the right too, the color variation. It has these kind of gold tones and then the gray, and that's what the building is too, right? It's the technology, the photovoltaics, and then we have that warm kind of ochre terracotta material. So it's really kind of inspired almost by the kind of the campus stone into this new manifestation of the building.
Nice.
And just to let you know, Evan, yes, many of the East Coast universities have their own quarry that they control that is specifically for their campus buildings.
In California, they have their own stucco quarries.
Yeah. So this is it's always these projects. Of course, there's so many interesting stories during the construction, but I just thought so there are 5 planes. It's actually like a torn intersection because we have the start of the roof terrace at that same location. So all these points need to come together as one. And so, but all of these different systems have to come together here, and they have to perform, right? They have to be able to thermally expand. They have to be waterproof. Some of them are photovoltaic. Some of them have wiring in them. So it was just very interesting process.
You made this problem for yourself. I mean,
so they had to actually mill. This is milled out of a single billet in order, and it basically is the intersection of all the pieces that come together at that location.
It does not. It sounds expensive, Sven. It sounds very expensive.
But look at
that connection.
Gorgeous.
There's only one of them. And
can anybody see this picture of this thing on the right when they see the building, or is it completely hidden?
I mean, it basically, I think it's hidden because it's all butt glazed assemblies, so it's glass on top of it. But But I love just the thing itself is just such an interesting. It's got the stories. You could probably talk about just this one thing for a couple hours.
It'd be cool to have one of those like in the lobby, right? I mean, even if it's not a fully milled, expensive replica, it could be a 3D printed one, and it's like this thing came from outer space. This piece right here.
Exactly. Yeah,
it's very cool.
So is this unitized or?
It was all unitized, yeah. And so in this particular piece, they had to actually install it as one thing because the whole thing was put together in the shop, and then they hoisted it into place.
So dimension-wise, give us an idea of the overall size of this piece right here.
The aluminum or the piece, the actual window piece.
The aluminum, like just the connector.
The aluminum, it's probably 4 feet long at the longest dimension, maybe.
That's big.
3 or 4 feet.
Wow.
So, but yeah, they hoisted it into place, and there was another parallel one that they built at the same time because they had to do testing offsite, and so it was all tested to make sure that it worked as expected.
Wow, very cool.
So
5 planes coming together. So it's like that front corner right there.
Yeah.
Yeah, it's 1, 2, 3, 4, 5, but it's also torn. So it's really there's a 6th plane.
Gotcha.
That is the roof terrace. And so then the roof terrace, then of course has to be waterproofed. So, I mean, of course the facade is all waterproof too, but I mean in a different way with a different assembly. So it was just a really kind of a beautiful piece of engineering, that intersection.
Super cool little design problems that come along while you're designing the overall project, right? It's like, I mean, I can't really have to dig into that design problem right there.
Right. Yeah. And we have a building tech kind of component to the firm, and they do building forensics and stuff. But anyway, so instead of a consultant, we actually had them, but they spent a tremendous amount of time getting all this to work, working with the design assist team, the contractor, the fabricator, doing all the testing. There was just that one. There really would be probably a couple hours of conversation you could have just about that one element.
That's cool.
So not to stray too far from the conversation about the amazing building that we're seeing here, but you've mentioned multiple different inner firm disciplines, and here you are as the design director of this building. I mean, what are the challenges just in managing all of the different internal consultants? Because we already know, like, a lot of our external consultants are a chore and a challenge to handle, but then you are adding so many other different layers to this to make sure the outcome that we're seeing here is achieved. I mean, talk about that a little bit.
Yeah, so we have this internally. We had mechanical engineering, MEP, fire protection, life safety. We did landscape, but also the kind of the building tech stuff, the computational stuff. So it's all that stuff was in house, which I think made it a lot easier because it was really picking up the phone or just having a meeting with somebody who spontaneously. Well, it didn't have to be like a series of planned meetings. You're just saying we've got this issue, got this challenge, and then many of us have worked on other projects in the past too, where we've started some of these ideas, and this is like an extension of the conversation. Mm-hmm. So some of the systems, for example, so this is a diagram of the different kind of systems on the project. So there's the different PV. We also have like regular conventional rooftop PV up here on the roof terrace, but we also have this dark blue connection to a wastewater pump station. And that's for future use of sewage wastewater energy exchange. Mm-hmm. So it's basically using wastewater as a source, a heat source and sink. So it's just like geothermal, but using wastewater.
Like a biogas, kind of from an aerobic process. Like, biology is happening there, right? And they can capture that and send that back.
No, it's not the anaerobic digestion, because so some of the utilities in the region are doing that. But okay. This is really using the flow of wastewater as a medium for, you can extract heat from it in the winter and you can dump heat into it in the summer.
Interesting.
So it's exactly like geothermal, but instead of using the earth, you're using the wastewater.
How interesting. What a cool thing.
So we did that. So our engineering team did that for the first time in an office building in the US. Like a few years before that, it was another project, the DC water headquarters. But anyway, that project uses, it's for a water utility. So it sits on top of, it's an office building on top of a pump station.
Wow.
But anyway, that building taps into the wastewater, and that whole building is heated and cooled with this sewage wastewater energy exchange system.
Very cool.
So, but the challenge here was, so we said, okay, we want to do that here. But like I showed in the master plan, the neighborhood hasn't been built yet. So there's not enough wastewater. So basically we built a tunnel. So part of this project is a tunnel over to the wastewater station, so that in the future, this building and then the other two future buildings can use that as part of their strategy.
That's very cool.
Interesting.
So it's like so I mean, to answer your question about some of all these different challenges, but some of it are like a continuation of conversations from other projects or strategies from other projects, and we're just trying to figure out what's appropriate for each of these. So these are, and then there's geothermal here too, but that's all future. But and this is a municipal park, but Alexandria kind of indicated that it could be used in the future for geothermal. So we have the connection already in place.
Very cool. So where do we go from here?
You want to check out the interior?
I would love to see the interior of this building.
So main lobby. So the ground floor. We have a large auditorium in the center. Labs are typically on the west side of the building, the high performance labs. And then more of the kind of interaction and collaboration spaces are all in the east because it's facing the campus.
Can we talk about structure again real quick here? Because this is a problem, challenge, however you want to put it, I've had on previous project where you've got labs up above that are on this lab module structurally, and then you come down and on the bottom, of course, you want to put the auditoriums down there because you want access, and they're on the first floor, and maybe you got a higher floor-to-floor height and all these things. So how did you handle, what kind of structural system is this building using, and how did you handle where you obviously don't want columns coming down in the middle of your auditorium?
Yes, it's all steel structure with steel and composite deck, and so we do have a few kind of large girders,
big transfer beams.
Yeah, over this auditorium here, but most of the rest of it is kind of on grid.
On the module.
And there were just a handful of things here we had to move.
And I think you mentioned this earlier, but I mean, this had to meet some level of vibration criteria.
Yeah, so basically what we did is the whole kind of west side of the building met the criteria, and that's where we have all of the kind of high performance labs. And then the north and south are typically more like office space lab suites, but it's more like office space. Classrooms in the center, and then again the collaboration space is all on the east side.
So you kind of zoned it programmatically on the interior so that you could pick your battles when it came to like how much vibration control you needed. Like you could focus it in a certain area.
Yeah, and to your earlier question, not only are they zoning it that way, but they're zoning it structurally as well. So, certain the west side of this is meeting a certain criteria versus the east side that isn't as stringent as your west side. If I'm reading what you're saying there, Sven.
Yeah, no, that's right. And then any kind of expansion would have to happen in those zones, in the future.
Right.
This is the main lobby. So you can see we have a 70-foot skyfold partition here. So there's a 300-seat assembly space, and so it's a lot of times actually you go to the site and it's up, which is nice. They might have an event in here or something. It kind of spills out to the lobby, and then you get the view of the campus. But I think a lot of the kind of the main idea here is just we have all that kind of folding and warm tone on the exterior, so how to bring it into the interior so you can experience it, because otherwise you wouldn't know any of that's happening on the exterior. So we have a wood soffit on the perimeter that extends into the space, and then it folds down to the floor where it becomes tactile at the stair. At the end there's kind of a sculptural stair, and then you can see behind the reception desk too, there's an area where it kind of folds down to the ground where you can sort of touch it.
You can sort of see that, obviously these are acoustic panels, but is the larger patterning something that's somewhat mimicking the pattern that you have in your photovoltaics?
Yeah, I think we tried to just to break down the scale of it. So, the photovoltaics are all, it's a grid, a square grid, but these are, so it's like a circular version of that where they're these kind of densities of perforation that happen in different parts of the lobby, like mostly like around the entry zones, sort of like where there's activity of people. And there's sound text absorptive material behind it. So it's we have micro perf on the wood, but also the larger perforations are acoustical as well. So, and then it gets a sort of a more intimate zone to hang out underneath the stair in the lobby.
It's that hokey orange, huh?
Yeah, it's one of their colors. And so this is that kind of large classroom space that it's used for all kinds of different types of functions, as you can imagine. So it is a 2-story kind of space.
2-story atrium.
Yeah,
it's nice.
Not an atrium.
Yeah, it's not technically an
atrium.
What label did you put in the plans in that space?
Yeah, you just called it lobby, 2-story lobby.
Mm-hmm.
Lobby mezzanine. It clearly states it right
call it an
there.
atrium.
Right.
Call it an atrium.
So there's a sort of a wellness ecosystem in the building. So there are stair count graphics when you enter the fire stairs, which have fiberglass on them, so you get to know how many steps you're taking. And we have these kind of drive-by meditation areas where you can do some stretching or.
That's a new term.
Drive-by meditation. Love it.
You're stressed out between classes. You just need a little bit of a break. So.
It's a no-phone zone.
Yeah, exactly. So just to orient you, some sections, elevations. So this is really experience, behind the...
This is a scene from a sci-fi movie right here. That's what this is some storyboard art for, then we go into this space and you've never seen it before.
I mean, it feels like you've just done this kind of like shadow waffle slap.
Right. Yeah, I mean, I think it's like if you're walking in a forest or something like that, and you get these kind of light through the leaves, and it continually moves around. So it's just a very kind of has a very natural feel to it. I think those kind of dappled light that you experience it in different parts of the world, right? So, but it's got a very soft. There's a very soft light. I think you don't need your point about glare earlier. It's really modulating the glare, but you still get the views. You still get expansive views, actually.
And how much space is in between those photovoltaics, just to get an idea of the scale there?
I think it's like 1.5 inches.
Okay.
And so we did mock-ups of everything from 1/4 inch to wider. And so actually, and to I think it's surprising because until we did the mock-up, I really did not expect this much light to come through it. Right, because if somebody said, "Oh, we've only got 1.5 inches between these cells, and it's going to be just black squares," you really wouldn't think it would be this kind of immersive quality of light. But
yeah.
Was there cost implications in that spacing when it came to like coming up with different spacing ideas? Was that part of the equation or not?
No, because it's all custom anyway, so they can lay it out however you want. So
it costs all the money no matter what. So yeah.
Well, I mean, and of course, the denser, the more power you're generating, right? The more of these that you can fit on the glass. So it's that whole balance of like how dense do you want it to be? You want to have views. You want to get a kind of a nice quality light coming through the spaces. So it's again, it's just balance.
Interesting.
How did you protect the design? Because obviously there are a lot of things that we're seeing here, and there are easy choices for a client to say, well, that's great, like it, but that's going to cost a lot of money. Let's get rid of it. How did you defend the design?
Well, right. There's always that pressure for the entire duration of the project. We had a great client who who supported the design, but of course they were under pressure to get the cost to be on budget and on schedule and on budget. So the university architect was very good about, for example, the terracotta was at risk for much of the project. And so, but she was really an advocate for it. Again, it's a 100-year material.
Right.
There's so many kind of great attributes of it. And she really wanted to kind of maintain that warmth, the photovoltaic. So there are a lot of things, of course, that are that were removed from the project. There's the very top of the tower, there was more photovoltaics that were supposed to be there, more conventional ones. But that's a future phase that can go in anytime. Part of it was, I think, because of the speed of the project and because of the entitlements process, we locked in the major attributes of the project very early on. So we had to find a way to make it work. If something was over budget, we just went through all the machinations and permutations until it was on budget, because we had already presented it to the state and to the local and authorities, and it had been approved, and it was really difficult to go backwards. So I think it was a combination of the schedule, great support of the client, and then just a tremendous amount of work on the part of the team to really figure out and optimize a lot of these systems. So there were so many different versions of everything that you're seeing, and so this is the final version.
Oh yeah.
But there were so many others, and so but I think we were able to keep the significant attributes of the building.
I mean, if I didn't ask you that question, I'd be looking at it and I'd be like, "This is amazing," and then thinking to myself about the multiple times that I've gone through the value engineering process, both during the design process, but then also after the bids come in. When you're always fighting for that, and that's usually the first low-hanging fruit that people go after, is changing this or changing that. And so in what we see here is, even if you were going through that process during the design phase, it looks like it's always been very well maintained, the kind of design philosophy, where even if you were maybe changing to a cheaper material or something like that, that knowing the overall vision of a design kind of kept you pulling that through, even with the sacrifices.
Right. Yes, I mean, one example is I showed earlier the yellow spandrel glass. It's the kind of the edge. So initially that was going to be terracotta, but then it required kind of an inset, a pan kind of within the unitized system, and it had this crazy waterproofing detail, and it had to be able to weep, and you're dealing with more of a dimensional. So that was something where it was just getting too complicated and too expensive. So we found that we didn't want it to be glass, but the acid etched glass has this beautiful softness that's very, very compatible with. And then that's very easy to put, of course, in as part of a unitized curtain wall system.
And was that a choice that you made, or was that a conversation with both the client and your design team?
Well, I mean, it was a budget thing, right? So we had to, the whole team had to come together with the client and just say, so we have to figure this out. We want to maintain the design intent. How are we going to do it? And then iteration after iteration, that's what we came up with. So it worked out.
Excellent.
So let's see. I think there's just probably a few more things, but this is on the west side of the building, which is kind of simpler, kind of more urban. You can kind of see into. This is one of the kind of lab spaces that you can see into where they do their projects, work on projects, and build things.
That's that
kind of
good old
interior
tower that just reinforces that the beautiful kind of like honey kind of terracotta there.
Exactly. Yeah. And here you can see actually we have a graphic of those building form diagrams on a wall behind this space. It was that animation that you saw earlier. So we actually have like a super graphic back here showing this. This is a drone cage. I think it's nice to see a lab space with great light, right? Great natural light. And then this is the west side, so this has very deep fins that are actually even canted. For some reason, we found that they were more effective if they were canted slightly north. But that was true on the west, but not on the east for some reason. So but that's how they are. So you get to see them through the window. Learning Commons. So this is like the 5th floor, that basically again with views to the east and everything.
Are there multiple programs, educational, like academic programs in this building, or is it all one? Is it all computer science?
No, it's multiple. So computer science, computer engineering, which are very different flavors, related, of course, but the business school has a significant presence here too.
Okay.
which is very kind of independent. It's not just business school as it relates to computer science. They have all kinds of different programs. But then there are lots of other ancillary programs. There's one called Executive Masters of Natural Resources. So again, this is all masters and PhD projects, or classes. So that's an executive day. So they have students come in on the weekend and learn about sustainable systems and policy.
Yeah, I was going to say policy,
and they're
especially
able
around DC.
Exactly. And so they're able to use the building as a tool, actually. So we've had a lot of connectivity with that program.
That's very cool.
So this space is kind of interesting, just that you get the different systems, right? So you get the horizontal PV over here, and then the building integrated photovoltaics at the end.
On the corner, different orientations. Yep. Yeah, that's cool.
So, but and you can see how effectively it shades the interior. Again, it's not that harsh, bright light. You get the views, but it's a very soft light.
Nice.
So, and then you get up to the top, you get the roof terrace, which really has these phenomenal views of the whole region.
There's that Alexandria brick and
all this stuff over here. Yeah, exactly. So more roof terrace, and then of course the night shot,
the money shot. Very cool.
So that's really the main attributes. I guess that one interesting thing that you might see from here. So this is actually that treehouse, that interior that you just saw. You can see how it's kind of all lit up because it's the whole width of the building at the south. Yeah. I think this is interesting in that one of the goals for the project was not to express a mechanical penthouse.
Yeah.
So you never see the mechanical penthouse. So we do have some equipment. There is a kind of a well up here, but most of the mechanical systems are all kind of tucked away in here. And then this is it's a corrugated, perforated metal panel. So behind that are all the louvers.
Okay.
So what drove that, Sven? Was that really about maximizing roof area for PVs and things like that, or was it something else?
Well, I mean, I think there was just we didn't want there to be an expressed mechanical penthouse. We didn't want there to be a back door to the building either. So even like the loading is all kind of concealed. And so there was sort of the design driver of it. And I think so. There's basically just this one. This element is the only thing that is really expressed.
Nice.
So, but it's another shadow. It also has a kind of vertical corrugation to it, so it adds more shadow pattern. But I think it's interesting too that there's no architectural lighting on the project, but because of the terracotta fins on the west and that they're angled, the interior light gives them a kind of a strong glow.
Oh, interesting. So it's just illuminated from the interior. That's cool.
Yeah. And then here you see more of these urban windows where we've started to kind of erode the facade to kind of express some of the interior program.
Nice.
So,
well, it looks like an amazing project, and I would imagine this is kind of one of those things where a lot of learning obviously came through the design process, but also there's a ton of opportunity to continue the learning because you've employed so many systems on this. Is there any kind of continuing analysis going on with this project? I know that's kind of rare in our field maybe, but depending, when you have a relationship with a university, maybe there's more opportunity for things like that.
Yeah, no, that's exactly right. We're working on that right now, actually. So they've got kind of a dashboard where they can kind of monitor everything over time, and we're trying to coordinate access to the data so we can help to fine tune everything and learn from it too.
Excellent.
Very cool.
So I'm going to be asking this question a lot in the coming week because my studio for the semester is coming to a close. And one of the things that I always like to ask students, especially when they're living in the moment so much and they get frustrated with the project over time and everything else, and a lot of times they don't take that moment to like step back and take a look at the project. So I always ask them, what was your favorite thing about this project? So Sven, I'm going to ask you, what was your favorite thing about this project?
Yeah, no, that's interesting. A couple of things, but I think one is that the scale of the project is interesting in that you really see it from all over in the region. Yeah. But that's where the the faceting in the form really contributes to that experience. So if you see it across the river, sometimes you'll get a glint of light, or you can see it from some of the rooftops in the city and you see the silhouette, which is a little bit kind of atypical for the area, right? Everything is sort of this extruded form. So I think kind of, I really just, I appreciate that. And then, as I mentioned earlier, I think just when you're in the building, the sense of light and shadow is really something for the occupants to enjoy, I think, over time.
And
I would say that seems really successful to me in that you're creating, there's some like level of interactivity to me with the building and its environment. And so when you're in the spaces and they're just constantly changing is probably a really cool thing that you don't get to experience in too many buildings. Of course, yeah, okay, my living room is different in the summer than it is in the winter. But this, because of the level of detail and kind of the specificity of like these different surfaces and orientations and patterns and all those things, it's just kind of a different mood almost it's going to be way different if it's
every day,
kind of overcast day versus a sunny day, right? And those 2 days could be right next to each other. You don't have to wait a whole season to experience that. And I imagine that's pretty cool part of experiencing this place.
Yeah, it's very site specific, right? It was designed for this location, for this geography. Everything about it is site specific. So I think, but that means it has attributes that are unique to the site, and you can experience them that way.
Yeah, I mean, there's elements to this project that reminds me of like the Seattle Public Library, right? Which is obviously you have this skin that kind of wraps you went about it a completely different way than they did, right? They stacked program and then they shrunk wrap it basically to get the overall form. You started with the form and then you worked in, but I think what both of these projects share is that as someone experiencing it, I want to experience all the spaces, and I want to find those cool spots at different times of the year, and it encourages kind of this exploration of place. And there's so many variables going on here that it just really accomplishes that. And I feel like the Seattle Public Library is similar in that it's like, oh, I want to do the ramp. I want to find the red room in the middle. I want to find, and there's different, it's like it encourages interactivity with its occupants. It's not sterile. It's not expected. It's not just rectangular rooms side by side by side by side. You've got all of these different elements coming together, and it really kind of encourages curiosity and exploration. And I appreciate that about this project. So good job, man. This is awesome.
Yeah. Well, thank you. I think we had a great team. We had a great client, and that's, I think, the contributing, the factor that made it a success.
Yeah.
So
awesome. Well, Sven, thank you so much for taking the time to share this project. It's been a fun conversation to get to nerd out, I guess, on architecture and talk about the connections and the details and the overall ideas. And it's been a pleasure having you on the show.
Yeah, I enjoyed the conversation. Great questions. Yeah.